this question is from the Stewart-Davidson worksheet, and it's question number 6, and it says, sketch the graph of the continuous function that satisfies all the following conditions. So there are 3 conditions here. Just don't forget about, there's actually 2 more down here, D and E. So the first set tells us some y coordinates. So in this case, we're given some x and y coordinates. So I'm just going to make a table of values here. At x equals 0, y equals 0. At x equals 3, y equals 0. At x equals 1, y equals -2. And x equals -1, y equals -2. Okay, so that's what the first line tells us. It tells us that the derivative at -1 and +1 is equal to 0. So we should be able to find min and maxes potentially at those 2 points. So I'm going to do a slope chart. At x equals 1 and -1, we have slopes of 0 and 0. So for slopes less than -1, the slopes are going to be negative, less than 0. So I'm going to have negative slope like this. Between 0 and 1, x is 0 and x is 1. We're going to have, it's going to be negative for this region and this region. So between 0 and 1, we also have negative slope here. And then we'll have positive slope from -1 to 0. So we have positive slope here. So it's going up. 0 slope, 0 slope. And from 1 bigger, we're going to have positive slope. So it's going to be going up like this. Okay, so this is what my slope chart is going to look like. So it looks like it's going up like this. We don't have anything happening. We're not told what's happening, how it transitions from positive to negative at 0. So we're going to assume that this is a non-differentiable point because no derivatives are given at that point. So looking at the other information, talking about the second derivative now. Okay, so this is my second derivative, and it's going to be given this line here. The second derivative is greater than 0 for x is less than 3, not equal to 0. So again, the second derivative is not defined there. And then the second derivative is less than 0 for x is greater than 3. So if I have 3 here, okay, it looks like there is, at x is 3, it doesn't tell us what's happening at x is 3, but we know that. Okay, so I'm just going to maybe make that. And at x is less than 3, it's going to be concave up. So it looks like it's concave up through this region. And across that point, it's still going to be concave up. And it looks like it's concave down in this region. So we're not exactly sure what's happening at x equals 3. And then lastly, it says the limit as x goes to 1 is x goes to infinity is equal to 1, and x goes to negative infinity equals infinity. So these are endpoint behaviors, so these are to do with asymptotes. First, I'm going to draw this in. And -1, -2, maybe about here. Maybe I'll just draw it a little bit over. -1, +1, -2. So maybe a point about here. 0, 0 is a coordinate, so there's something happening there. And at 3, there's also a 0. At x is 3. Okay. And I've been told I'm going to use my endpoint behavior here just to figure out what's happening. This is as x goes to infinity, y goes to 1, so that's going to be a horizontal asymptote at y equals 1 to the right, and it's going to shoot off to infinity. Okay, so it's going to shoot off to infinity as we go to negative. So what we should expect is some graph that's going to go from way up here. It's going to come down. That's going to be a minimum point for my graph. This looks like it's changing from positive to negative abruptly. So that's a cusp. Okay, so that's going to be a kink. going to be concave up. It's going to, we don't have any 0. We have a coordinate here at x equals 3, y equals 0. Yeah, that's a point. So it's going to come through here. And then it looks like it's going to change concavity across that point. It's going to be concave up and then concave down. It's going to follow our asymptote that way. So there is what our graph should look like. It should come up, have a kink there, minimum, go through the 0, change concavity, and follow the asymptote.